Okay, so for my question, I'm doing number 2, and it says a plant geneticist has 2 pure lines, one with purple petals and one with blue. She hypothesizes that the phenotypic difference is due to 2 alleles of one gene. So to test this idea, she aims to look for a 3-to-1 ratio in the F2, which is the second progeny. She crosses the lines and finds that all the F1 progeny are purple, so all of the first progeny or offspring are purple. The F1 plants are selfed, and 400 F2 plants obtained, so that's going to be your total number of plants obtained. Of these, 317 are purple and 83 are blue. So we're going to use a chi-square test to determine if these results are consistent with her hypothesis of the 3-to-1 ratio. So we're going to start by listing the formula for the chi-square test. This formula is the sum of the observed minus the expected values squared over the expected values. Okay, so now we have that formula, we can begin. So there are 2 pure lines. We have purple, that's me 1, and then we have a blue. And we have our observed values, expected, and then we have the observed minus expected squared over the expected. So we have, and then we have the total, which is going to be 400 for each one, since that is the amount of the F2 plants obtained. So then for purple, she observed 300, or the geneticist observed 300, and then for blue, they observed 83. So since we have a 3-to-1 ratio, this means that out of the 400, 3-to-1, assuming purple is dominant, we're going to have 300 to 100. If you simplify, it would be 3-to-1. So then we got to figure out the chi-squared. So we will do the observed for, let's do purple. We're going to do 317, the observed, minus the 300 of expected. Got to square this over the 300 of expected, and you get 0.96. Now for blue, we have to subtract 83, which is the observed, minus the 100 of the expected, over 100, this has to be squared, over 100 for the expected, and you get 2.89. Now these numbers, these totals, you put up here since that's what you worked out. So you get 0.96 for purple, and then 2.89 for blue. Now, the chi-squared test is the sum of these two. So we're going to add 0.96, you're going to add 0.96 and 2.89. When you add these, you get 3.85. For the chi-square test, we have to have a degrees of freedom, which is equal to the number of the phenotypic classes minus 1. So the phenotypic classes, we have purple and blue, so we have 2. So the degrees of freedom is going to be 2 minus 1, which will equal to 1. So these numbers, the degrees of freedom and the 3.85, which is the sum, or the chi-square test, we look at a distribution of numbers. So when we have 1, and then we drag it all the way down to between 3.841 and between 5.024, because it'll be in between the 5% and the 2.5% probability. That so this basically shows that we know that there is between a 2.5% to 5% probability that the deviation between observed and expected values is not due to chance. This means that this is not consistent with the 3-to-1 ratio.